Welcome to The Explainer. Today we're talking about a design pattern that's famous, maybe even infamous. It's the singleton. You see in all the textbooks, but ask any seasoned developer and they'll probably tell you to steer clear. So what's the deal?
Right? What if I told you that one of the most well-known design patterns is one that a lot of experts say you should just avoid? The singleton is often called a code smell. You know, it's like a warning sign that something deeper might be wrong with your code's design. So how does a pattern that's literally in the book get such a bad reputation? Let's dig in.
Okay, so before we tear it down, let's build it up. We have to understand what the singleton is supposed to do. What's the official promise here?
And there it is, the textbook definition. The singleton pattern ensures a class has only one instance and provides a global point of access to it. It's making two really specific, really bold promises. Promise number one, it guarantees you can only ever have one of these things, just one. And promise number two, it gives you a single global spot to get a hold of that one thing. And that's the absolute key right there. It has two jobs. It's not just about having a single object. Lots of apps have that. It's about the pattern forcing that rule on you, making it impossible to create more than one. And at the same time, it's acting like a global signpost for your entire application. These two promises, they're everything. They're the whole story.
All right, now for the fun part. Let's talk about why those two promises, the very things that define the singleton, are actually the source of all the problems. It's a classic case of the solution being worse than the disease.
So the case against it really comes down to two big things. First, that global access point, that's just a fancy way of saying you've created a global variable. And what's one of the first things they teach you in Programming 101? Avoid globals. They make your code a tangled mess, because anything from anywhere can reach in and change things. It's unpredictable. And second, there's the only one assumption. You are literally betting the future of your application on the idea that you will never, ever need more than one of these things. That's a pretty bold bet to make.
To see just how risky that bet is, let's use an analogy. Imagine you're building a chat app.
When you first start, things are simple, right? Your app just needs one big main chat room for everybody. So you think, hey, I'll make the chat room class a singleton. It seems smart, it's convenient, it guarantees everyone is talking to the same exact room. Makes perfect sense, at first.
But then, your app is a hit. It blows up. It's a huge success. And with that success come new demands, new feature requests, things you never, ever could have predicted back on day one.
Now your users are asking for multiple private chat rooms. But you've got a problem, a huge one. You literally can't create a second or a third or a fourth chat room. Why not? Because you hard-coded the only one rule into the very DNA of your chat room class using the singleton. The very thing that seemed so clever at the start is now a roadblock, actively stopping your app from evolving.
And oh, it gets worse. The problems don't stop there. For one, the singleton violates a really important design rule called the single responsibility principle. It's doing way too much. It's managing its own creation, it's enforcing this one instance rule, and it's trying to be a chat room. On top of that, it makes testing an absolute nightmare. You can't just sub in a fake version for your tests, a mock object, because the entire point of the pattern is to stop you from doing that. It's designed to give you that one real global object, no matter what.
This quote just nails it. One man's constant is another man's variable. It perfectly sums up the core problem, right? You're making a permanent decision today based on what you know right now, assuming something will always be a constant. But you have no idea what tomorrow will bring. The future might need that constant to become a variable.
So how does this thing actually work? How does the singleton pull off this clever but kind of dangerous magic trick? Let's pop the hood and look at the mechanism it uses to enforce its own rules. It's basically a three-step process that uses what are called static features of a class. Think of it like this. It locks the front door so no one can just walk in and create a new object, and then it gives you a special, single key that you have to ask for. Okay, so the first step, the secret sauce really, is something you might not even know you could do. The class makes its constructor private. That's the whole game right there. By making it private, it completely stops anyone else, anywhere in your code, from just creating a new instance. The door is locked. But wait a second. That creates a weird problem, right? If no one can create an instance, how does the first one get created? It's like a chicken and egg thing. Who has the key to this locked room? The answer is, the class creates itself. It has a special public method, usually called something like getInstance. And since that method lives inside the class, it has a special key. It's allowed to call its own private constructor. So the first time you ask for the instance, the method checks, sees there isn't one, creates it, and hands it to you. Every single time after that, when you ask, it just gives you back that very same one it already made. Simple as that?
Okay, so if the singleton is so flawed, what's the alternative? What are you supposed to do when you genuinely do only need one of something in your app, at least for right now?
This quote from Misko Hevery really hits the nail on the head. He says, it's completely fine to have a single object, but it's not fine to force it to be impossible to create a second instance. And that's the whole philosophy right there. The problem isn't having one object. That's fine. The problem is building a class that handcuffs you, that makes it physically impossible to ever change your mind later.
So here's the big takeaway. You want to separate what you're doing from how you're doing it. Let your application be the one that decides to create only one instance. That's your application's policy. But don't bake that rule into the class itself. Keep the class normal and flexible. That way, if your policy needs to change tomorrow, your code isn't fighting you.
In the end, this whole discussion about the singleton pattern is about more than just code. It's really a lesson in design philosophy. It's a reminder to always ask ourselves this critical question: when is this good enough solution